Right, thank you. Today we are looking at step by step on how to install solar and inverter system. Step by step. Step by step. Step by step on how to install solar and inverter system. Solar and inverter. This is the topic we are looking at today. Now, as we are looking at this topic, there are some materials that we needed. Materials that we needed. Number one, solar panel. Number two, charge controller. Number three, solar battery. Number four, breaker box. Number five, appliances. Number six, we have power. We have power inverter. These are the 6 primary items we need for the installation of solar system in our home or in the offices. Now, we want to take it one after the other so that we can do the connection. You will see how the connection is. We'll start with the solar panel. We'll start with the solar panel. Solar panel. All right. Now, we are looking at this solar panel. Pause.
Continue.
Mm. So this is the solar panel. As you can see, this solar panel converts the sunlight into electricity by using photovoltaic cells. The photovoltaic cells are made up of materials that produce excited electrons when exposed to the light. And because of that, once the light is shone on the panel, it produces electricity. Now, the electricity that the panel produces is DC, direct current electricity. That is what it produces. So after the panel produces the electricity, it sends it to the charge controller. Some people thought that it will be connected to the battery straight. No, to the charge controller. That is number 2. Number 2 now is what? Charge controller. Charge controller. So we are now using the charge controller we are now looking at the charge controller. Now, on the charge controller, you will see that these 2 terminals are for panel input. The following 2 terminals are for battery, and the last 2 terminals are load. That is the DC load. Now, as the panel supplies from the panel, the power goes straight to the charge controller. It goes straight to the charge controller. What is the purpose for the charge controller? A solar charge controller is an electronics device that is used in off-grid and what hybrid off-grid applications to regulate and to control the current and voltage input from the PV, that is from the solar panel to the battery, so that if the battery is fully charged, it cuts off the power automatically. And in the night, when the battery, when the panel, no power from the panel anymore, it will not allow the battery to discharge back to the panel. So it regulates the current and the voltage between the battery and the panel. Now, as it is connected like this, it is supplied to it. From there, we have the battery. We are using 2 batteries. We are using 2 batteries of 200 amps, 12 volts. And this charge controller is 24 volts charge controller. Therefore, as we have 12 volts, battery 1, battery 2. Now we have this battery 1 and battery 2, number 2. This 12 volts, 200 amps, 12 volts, 200 amps. Now, at this point, we'll connect them in series to give us the output. We'll connect the battery in series to give us this output. Meanwhile, have it in mind that solar battery are an energy storage system designed to back up, so that when the panel, at the point that the panel will not be receiving light again from the sun, it will now, the battery will give power to the house or to the load, as the case may be, because it is designed to store the energy generated by the solar panel until the household need it, until the office need it. It will now give it out. Then, from the charge controller, this is the positive terminal. From the charge controller, it comes straight to the battery. And this is the negative terminal. From the charge controller, it goes straight to the battery. Now, at this point, you are being able to charge the battery using your solar panel. Now, in the using of your solar panel, you are able to charge the battery. But what about the load? This terminal, we have DC bulb. in a power system, we have DC appliances, we have AC appliance. So if your house is wired using DC appliance, you can pick it direct from the charge controller and power the house. You may not need inverter. But most at times, the house are wired with AC standard. And for that reason, you need to convert the DC current produced from the panel, say in the battery. You need to convert it to AC before you be able to power AC appliance. That is AC bulb. So this AC appliance. Now with this AC appliance, you need to convert the DC you need to convert this DC current to AC before you supply it. And that brings about what? The inverter. So you get to bring inverter in at this point. You need to bring inverter in at this point because inverter convert AC current, DC current to AC and AC current to DC. Most especially hybrids, when it's connected to a utility, it still uses utility to charge the battery. When the panel is full in the battery, it converts it to AC and give it out. So we have two AC input and output from the on the inverter. So this is the inverter. This is DC input. AC input and AC output. AC, the inverter. This is power inverter. Now, since the inverter we have is 24 volts DC, that is to say that this positive terminal and this negative terminal comes straight to this negative terminal. And this positive terminal comes straight to this terminal. So that the moment this cuts off, the moment there is no power from here, it will pick from here, convert it, and supply to the appliances. This live and this is neutral. So this is live and neutral of the output. This is live and this is neutral. So this neutral now will come straight inverter will supply it, and this live comes straight to the live terminal. At this point, if you don't want to use utility to charge the battery, or sometimes when there is power failure and the battery is not properly backed up, if you don't want to use the utility to charge it, you may not connect it. But if you want to use the utility to charge it, this is the input of the utility. So now this is the national grid. This is the national grid. So your positive terminal, this is live and this is neutral. It goes straight to the input, and this live goes straight to the input live, while neutral goes straight to the input neutral. So this is the live now. Input live comes straight to this. Then the input neutral comes straight to this. At this point, you have finished the connection, the direct connection you needed for your solar system to work perfectly. When you do the connection like this, it will work and give you what you want. But there's something that you need to understand. And what is that thing that you need to understand? This panel is prone to thunder strike So there is a need for you to protect this man, your charge controller, and to protect your inverter from surge. And that is where we bring in the breaker box. That is where we bring in the breaker box. This breaker box is so important that is the hub of the electricity that is served as the protective device for the inverter, the charge controller, and the appliances in the house. Because the power will go through it before it gets to the charge controller. So that is to say that this point there will be a breaker box here. That means there will be a breaker box. What are the things that will be inside the breaker box? DC surge will be inside the breaker box. DC breaker will be inside the breaker box. Now, the DC surge is like this. Do you see the way it appeared? Now, we need two-pole circuit breaker also, which will be here. This two-pole circuit breaker will be DC breaker. Anything in this box, provided it serves intermediate between the panel and the charge controller, is going to be DC. Now, your X continuity, this one straight to the ground. The earthing system in the building. This one straight to the ground. Now, this input, breaker input. So we have positive and negative. This negative of the breaker goes straight to the negative of the surge. And this positive of the breaker goes straight to the positive of the surge. Now, from the panel, the negative goes straight to the negative terminal of the breaker. And the positive goes straight to the positive terminal of the breaker. Thereby, the output of the breaker goes straight to the charge controller. This positive This is how your inverter system ought to be connected. Do you enjoy this class? Share and like. Thank you. As you meet this evening by 6 p.m. for the live streaming. Thank you.